Section 11.1 is on simple interest. So we're going to start leaving the introduction section, which was 11.0, talking about, look, we can deal with money and lots of money, millions, billions, and trillions of dollars. And we're going to break it down and go back to the small. What's the formula? How does that money grow? How does it get so big? Well, we're going to look at several different interest types. We're going to look at simple interest. We're going to look at compound interest. We'll look at different formulas for like buying houses and everything. But that's the idea of this chapter. This chapter is about finance. How do you make investments? How does money grow? When you loan, when you take a loan, how does that work? And that's what this entire chapter is about. So we're going to start off with some very simple linear growth, some simple interest, okay? And let me give you the general idea of simple interest. Well, let's go ahead and read these paragraphs because it gives us kind of a nice little idea of what's going on here. It says, when you deposit money in a bank, for example, in a savings account, you are permitting the bank to use your money. The bank may lend the deposited money to customers to buy cars or make renovations on their home, whatever they want, right? The bank pays you for the privilege of using your money. That amount paid to you is called interest. So interest is why they're giving you interest is because they're loaning your money out to other people and they're collecting fees, which is also called interest, for loaning them money. So here's the funny thing though, is when they pay you interest, they pay you a horrible low rate. For instance, Wells Fargo, one of the biggest banking industries, if you have a typical savings account, they pay you 0.01% interest for borrowing your money. So investing in a savings account is a horrible deal. I do not recommend it at all. I would recommend investing in a stock market or more secure, higher paying interest investments. So the bank gives you a horrible interest rate when they take your money, 0.01%. Yet when they loan that money out, let's say you buy a car and you're loaning that money to buy that car, they're charging you interest rates of 4, 5, 6%. There's a huge difference between the money they loan, 4, 5, 6%, and the money they give you, 0.01%. So I encourage you to look at your interest rates in your checking accounts and your savings accounts to see what types of interest rates you're getting and see if you can make some better investments. And we'll talk about those later on in the next sections. Okay? So it says the amount deposited in a bank or borrowed from a bank is called the principal. So the principal is the initial amount. The principal is always going to be the initial amount. That can be an initial loan or it can be an initial investment. It's one lump sum. You put money into an account and you leave it there, or you borrow that amount. So that amount, that initial amount, is called the principal. The amount of interest paid is usually given as a percent of the principal. The percent used to determine the amount of interest is called the interest rate. The interest rate, okay? So when you see principal, we're going to use the letter P. When you see interest rate, we're going to use the letter R. And that's written as a decimal. Written as a decimal. Okay? And so what I'm saying is 5% would be written as, 5%, you would use instead 0.05, the decimal version of this. Now, if you have the TI-30XS calculator, multi-view calculator that I suggested for this course, there is actually a percentage button above the left parentheses. You have to hit the green second key in the left parentheses. So you could put 5% into your calculator, but for any other calculator, if it doesn't have a percentage button, you have to use the decimal. And just to be sure, to make sure you're doing the right thing, I will always use the decimal version of a percentage in this class, okay? So let's continue. It says, if you deposit $1,000 in a savings account paying 5% interest per year, $1,000 is the principal and the annual interest rate is 5%. And I want you to note here that it's an annual interest rate that will change as we go through some of these problems in this section. It says interest paid on the original principal is called simple interest. This is a very important sentence right here. When you get interest on the original amount, when the interest is always on the original amount, that is called simple interest. The amount of interest you get every single time will be the same. Very, very important that you understand that. Simple interest is on the original amount. Your amount of interest will always be the same. That is going to be very different from compound interest, which changes based on the amount in the account and updates and changes every month or year or how often it changes. That's called compound interest in the next section. So the distinct difference is simple interest is always on the original amount. Okay? It says the formula used to calculate interest is, and here's your first formula, I equals PRT. I equals PRT. I here stands for the amount of interest that's measured in dollars. The amount of interest is measured in dollars. P is the principal, again, that's dollars. R is the interest rate, that has to be a decimal. Okay, so if you have 5%, it should be written as 0.05. And T is the time period. So what I want to write a note here, I'm going to say R and T must be the same time period. R and T must be the same time period. And what do I mean by that? What I mean is if your interest rate is annual, then your time has to be measured in years. If your interest rate is monthly, then your time has to be monthly. And that's going to make a really big difference for us in some of these problems. So if I told you my annual interest rate is 5%, my annual interest rate is 5%. And I invest for 3 years, you would have R would be 0.05 and T would be 3 for the 3 years. Now think about what if I said 16 months? Most people would say R is 0.05, the 5.5%, right? And then they would say T is 16. But that's not going to work because the time is measured in months and the rate is measured in annual, yearly, okay? So you have to understand the difference between those two. They have to be measured in the same. So what would you do in that case? What would you do if it was 16 months? Well, what is 16 months in terms of years? Well, when you do the conversion, 16 months is 16 over 12 years. There's 12 months to a year, so you divide it by 12. So if I were to do that, if I were to say 5% annual interest in 16 months, R would be 0.05, and T would be 16 divided by 12 to make sure that it's both measured in years. So that's something that you really, really have to pay attention to these problems is R and T must be in the same time period, both annual, both months, both weekly, whatever it is, okay? So it says in the simple interest formula, the time T is expressed in the same time as the rate. That is exactly what I just said right there. It has to be the same time period for rate and time. It says, for example, if the rate is given an annual interest rate, then the time is measured in years. If the rate is given as a monthly interest rate, then the time must be expressed in months. Interest rates are most commonly expressed as annual interest rates. Therefore, unless otherwise stated, we will assume the interest rate is an annual interest rate. So if they just say your interest rate is 5%, we assume that they mean 5% annually because that's the vast majority of times when we give percents, that's what it is. So if it does not state it, assume it's annual. It says interest rates are generally given as percentages, but performing calculations involving interest rates, you have to write it as the rate as a decimal. Okay, so again, really important there, the interest rate must be written as a decimal. So R here, instead of using 5% or the number 5, we would use 0.05. So what are we going to do for all of these problems? And this is going to be pretty much the exact same process for every problem for this entire chapter. Okay, so you've got to get used to this process. You always want to identify your variables. When you read a problem, they're all word problems. Circle it and tell me what that stands for. This number is P. The $1,000 that they talked about above was the principal. I would circle it and write P. 5%, that's the rate, so I'd circle it and I'd write R equals 0.05. So you want to identify your variables, okay? You need to identify the formula you're using. So far, we have the formula I equals PRT, but I'm telling you, by the end of this chapter, we're going to have probably 15 different formulas that we're using. So it's very important that you know which formula you are using. Once you know your variables and you know your formula, then you plug in the numbers for the variables. We're always going to have to use a calculator, or virtually always going to have to use a calculator for these problems. And then I want you to look at your answer, and I want you to decide if it's reasonable. First of all, reread the problem and make sure you're rounding to the proper point. They might say, what's your interest rate rounded to the nearest tenth? Okay, so it'd be like 5.2%, not 5.25%, because that's rounded to the nearest hundredth. So always reread the question and make sure you're rounding properly. If it's dollars, most likely we're going to want it with 2 decimals because you want dollars and cents. Sometimes it'll say to the nearest dollar. So just reread the problem, make sure you're rounding it properly. And I also want you to check it for reasonableness. And what do I mean by reasonableness? And this is going to be a big picture item for you. So I want you to understand this. So what do I mean by reasonableness? Here's what I mean. What if you invested $1,000 and you left it there for 5 years? What would you expect to have after 5 years if you invested $1,000? Well, on the test, I'll often see answers like $23. I would hope not. I would hope that you don't invest $1,000 and end up with $23 after 5 years. That $23 might be the interest, but it's certainly not the amount in the account after 5 years. So $23 is not reasonable as an answer. A negative number is not reasonable as an answer. If I invested that $1,000 for 5 years, $1 million is not reasonable for an answer. You wouldn't have $1 million in an account after 5 years for just investing $1,000. So I always want you to step back at the end, look at the answer and say, look, is it even reasonable? What would be a reasonable amount after 5 years? I don't know, maybe like $1,200, $1,500, $2,000, but certainly not $100,000. Okay, so check your answer for reasonableness. That's what I mean there. Always make sure you label your answer. If it's $1, you need to put a dollar sign. If it's a percent, you need to put the percent sign and write it as a percentage. Okay, make sure you've rounded properly, and that'll get you the final answer. So the bulk of the work, all the math, is going to be done in the calculator. The vast majority of it will be done in the calculator. So what I need to do is see you do all the rest of these steps to ensure you credit for the problem. You have to identify the variables, identify the formulas, plug in the numbers, use your calculator to get the answer, and then go ahead and label your answer and think about it. So we're going to use that process on every single one of the problems from here on out.